Well, here we are again, and today you're going to be learning about light and color. What do you know about light and color? You're going to find out if you don't know anything. Here we go. Light and color starts now. Today we're going to be learning about light and color, and we're going to look at what happens when you take a prism and you put it in front of white light. We're going to see what happens to that white light. So if you look at that, you'll actually find that white light contains all the colors of light, so all the colors of the rainbow. And in science, instead of calling it a rainbow, we actually call that the spectrum of light. So when we break up white light, it'll form the color spectrum in a prism. So here's a picture of that. And if you look at this white light coming through this prism, well, it breaks apart that different colors of light. And the reason that happens is because of the way they refract. So the red light refracts a certain amount, and then the violet light at the very bottom here refracts more, so it bends more as it comes through the prism. So we've got red light on top and violet on the bottom, and then all the other colors in between. Now they always refract in this certain order because of the wavelength of the light. So some light refracts more and some refracts less. So if we look at the different colors here, we'll start at the top with red, then orange, then yellow, then green, then blue, and then indigo, which is kind of like a lighter blue color, and then violet, which is like purple. So that's the order that the colors always show up in the spectrum. And there's a way to remember it. So if we look at the first letter of each color, well, it kind of spells out somebody's name. So their first name would be Roy, R-O-Y. Their middle initial would be G, and then their last name would be Biv. I guess that could be a last name, B-I-V. And that's how you remember the order. Like if you had a test or something, just remember Roy G. Biv, and that'll help you to remember the order of the color spectrum. Now, I have a question for you. What if I put a second prism upside down in front of this color spectrum here? What do you think would happen? Well, let's take a look. So if we put a second prism here, it actually combines that white light up so that it'll form, or sorry, it combines the colored light of the spectrum up so that it'll form white light. So we get white light being produced. Now, we're going to watch a little video about how a prism works.
Hi folks, here's a fun short science video showing how to use a prism to separate sunlight into a rainbow of colors. As you can see, with a little work and a sunny day, you can get a pretty nice result. I bought this prism at a local store called Focus Scientific that sells telescope and other optical equipment. It's a simple 5-sided piece of glass with 3 sides forming a triangle. To demonstrate it in action, I have this board on a tripod so I can arrange it any way I want. On top, I've taped these 2 pieces of cardboard with a small gap between them. I start by allowing only a thin slit of sunlight to go through this gap. That's to make sure that most of the light I'm using is coming from one direction only. As you can see, even with this paper far away, this light appears white on the paper. Now I put my prism in the way of the light. You'll notice that the light no longer continues in a straight line. And if you look closely, you can see all the visible colors that the sunlight is made up of. I'll be talking only about visible light in this video. Having found a good location for the prism, I tape it in place. How does it work? Visible light is made up of multiple electromagnetic waves with different wavelengths. Those wavelengths represent different colors: red, orange, yellow, green, blue, indigo, and violet. On this side of the prism, they're all overlapping and going in the same direction. But when they cross the boundary between the air and the glass of the prism, they bend. This bending is called refraction. When they exit the prism, going from glass to air, they bend again. The key is that the amount that they bend by is different because of the different wavelengths, or colors. The result is that red light will bend something like this when entering the prism, and like this when exiting the prism. But violet light will bend something like this when entering the prism, and like this when exiting the prism. So they enter going in the same direction, but leave going in different directions. And when we put this paper in the way of the light, we see the different colors separated. Putting the paper on a slant helps spread the light across more area, so we can see the colors more clearly. And that's how a prism works, to make a rainbow of colors.
Now, what do you think would happen if I took a prism and just put it in front of the different colors of light, like this red here, for example? If I just put a prism in front of only the red light, what would happen? Would it stay as just red light? Would it make some new color? Would it combine with other ones to make white light? What do you think would happen? Well, we're going to watch a Bill Nye video to see how that works.
Did you know that white light is a mixture of all the colors of the rainbow? It is. White light's hitting this basketball, but all we see is orange. And white light's hitting this blue gelatin dessert, but all we see is blue gelatin. On my coat, well, it's got lots of colors. Hey, it's the show about light and color. Now, without different colors of light, we couldn't see different colored things. And of course, without light, well, we couldn't have a TV show. Oh, funny. Oh, very funny. You can turn the lights on now. Turn the lights on.
Hey, you stepped on my foot!
Sorry. I got it. Now this is the plastic water-filled prism of science. And shining into it is a bright white light. Now when white light goes into a prism, it breaks up into all the colors of the rainbow, what we call the full spectrum of colors. So down here is the spectrum being made by the prism of science. See, here are all the colors of the rainbow. Red, orange, yellow, green, blue, indigo, and purple or violet. Now watch. I'm going to try to break these colors up using another prism. Red, yellow, green, blue, and violet. See, they can't be broken up anymore. What that means is these are pure colors. White light is a mixture of all the colors of the spectrum, but each color is its own color. White light is colorful.
Now we're going to watch a video of how rainbows actually form. It's a little bit of a detailed explanation. It's from the Discovery Channel. It's a bit old, but it tells you a little bit about how rainbows form and what angle you have to be at to actually see a rainbow.
For most of the winter, the only way we can get a little color in our lives is to hang prisms on our window. But summer's on its way, and that means we're going to have some color in the skies in the form of rainbows. And to talk more about rainbows, what they are and how they form, here's David Phillips. He's a senior climatologist with Environment Canada. Hi, David.
Hi, Judy.
Now, there's an old saying, rainbow in the morning, shepherds take warning, rainbow at night, shepherds delight. Is that true?
Yes, it works about 2/3 of the time in this part of the world. The idea is that in order to see a rainbow, you have to have the sun behind you and a curtain of rain in front of you. In order to understand that saying, you also have to understand that most of the weather systems in this part of the world move from west to east. Mm-hmm. So in the late afternoon, to see a rainbow, that means the sun is setting in the west, so you're seeing a rainbow in the east, and the sun is shining through clouds, so it's obviously clearing there, and the systems are moving from west to east, so what you're in store for is some clearing weather. But in the morning, of course, the sun is rising in the east, it's shining to the west where you see that rainbow. From where the weather is coming, it means probably rain that day.
Yuck. So I don't want to see any rainbows in the morning. Now, why do you always have to have the sun behind you and the clouds in front of you to see a rainbow?
It's all involved geometry of the sun through a raindrop. I mean, it's really a rainbow is the product of this certain angle between the sun's ray, the raindrop, and your eyes. Okay, and so sunlight will enter a raindrop at many different areas along that surface. Some of it goes right through and bounces back, and but there is a concentration of rays that enter the raindrop and refract. Mm-hmm. It bends. Mm-hmm. It of course slows down, and certain colored rays will bend less than others. The red bends less than the violet. Then those colored rays will enter to the back of the raindrop, will reflect off the back of the raindrop, and will come out at a precise angle, 42 degrees. There's a concentration of rays at 42 degrees, and will refract again and come to your eyes. Mm-hmm. And that angle between 40 degrees and 42 degrees is where all of the color of the rainbow is. At 42 degrees, we see the red light, and at 40 degrees, we see the violet light. And
now that angle is between you and the sun, is that the
That's
angle?
right. Between you and the sun coming in and the raindrop to you is at 42 degrees.
Okay. So the reason you get different colors is that each color bends a little bit differently, and you're just seeing actually the colors that are there in the white light.
That's right, and those colors, the separated colors, will all reflect off the back of the raindrop and come out, and that angle, we have to maintain that angle of 42 degrees. And every raindrop that is giving off color is giving it at that particular angle. And so when we look at that rainbow, we are seeing that red light coming to our eyes at precisely 42 degrees, and the violet light coming at 40 degrees, and all the other colors are in between.
So you can kind of see why you only see a rainbow sometimes. It's because, well, you have to be at that specific angle between 40 and 42 degrees to the raindrop, and have the sun coming in at the right angle hitting the raindrop. So it's quite a unique situation. That's why you don't see a rainbow too often. Now, something else we're going to look at today is additive primary colors of light. So the three primary colors of light are, I wonder if you can guess. They're actually red, green, and blue. So they're a little bit different than the colors you'd have in art class. So those are called pigments. And in art, the primary colors are red, yellow, and blue. With light, it's actually red, green, and blue. And those are called additive colors because when you add them together, what color do you get? That's right, it makes white light. So adding those three colors together will make white light. Now, when you combine those colors in different amounts, you get the secondary colors. And the secondary colors of light are actually yellow, cyan, which is like a light blue, and then magenta, which is like a different kind of shade of purple. So those are the secondary colors, and we'll look at that in a diagram next. So here they are. So if you start with red, green, and blue, those are our primary colors of light, and you mix them together in different combinations. So if we look at all of them together, we'd get white. So red, green, and blue mixed together makes white light. If you mix red and green, you get yellow. If you mix green and blue, you get cyan. And then if you mix blue and red, you get magenta. So that's how the colors work with light. Well, I hope you learned something about light and color today. We'll see you soon. Hope everybody is doing well. Bye.